Welcome to my algebra class. We're on chapter 10, section 6. There is no vocabulary for this. It's a continuation of the absolute value compound sentences. So your book should be open to 488. Head your papers, skip a line, and put the title down, and we're going to start with number 2. So it says solve each open sentence and graph its solution set. We have the absolute value of 5y equals 35. It's an equal to, so we have 5y equals 5, 35, or 5y equals negative 35. Solving for y, divide by 5, y equals 7, or y equals negative 7. And you can check those both work. So graphing the solution, we have our bullhorns. Put a dot at negative 7 and 7, and make sure the word or is there. Problem number 4, we have the absolute value of t over 3 is less than or equal to 2. It's a less than, so it's a between problem. We're going to put t over 3 between 2 and negative 2. To solve for t, we're going to multiply everything by 3. So we get negative 6 is less than or equal to t is less than or equal to 6. So t is going to be a Russian, we're going to find t between two numbers, Russian elbow. So we put negative 6 and 6, solid circle at both, shaded in between. Problem number 6, we have the absolute value of 3b minus 2 is equal to 7. It's an equal to problem, so we have the bullhorns. Equal to 7, the 2 dots, or 3b minus 2 equals negative 7. Solving for b, we add 2, and we get 3b equals 9. Divide by 3, and b equals 3. Or, the other possibility, solving the right equation here, we add 2, and we get 3b equals negative 5. Divide by 3, and we get b is equal to negative 5/3. In both of those work, negative 5/3 would give you negative 5 minus 2 makes negative 7, the absolute value is 7. And the 3 works, 3 times 3 is 9, take away 2 gives you 7. So graphing it, we have the bullhorns again. So put negative 5/3, that's negative 1 and 2/3, that comes between negative 1 and negative 2, and 3. And you put a dot here and a dot here, and here's your solution. Problem number 8, we have the absolute value of 5h minus 2 is greater than or equal to 8. Greater than is going to be your Egyptian dance. So we're going to have 5h minus 2 is greater than or equal to 8. Or the other possibility, 5h minus 2 could be less than or equal to negative 8. Solving for h, the first inequality, add 2. We get 5h is greater than or equal to 10. Divide by 5, and h is greater than or equal to 2. Bring down the or. Solving the second inequality for h, add 2. We get 5h is less than or equal to negative 6. Divide by 5, and h is less than or equal to negative 6/5. Graphing it, we have negative 6/5, negative 6/5 is negative 1 and 1/5, so that's between negative 1 and negative 2. and 2. And we have a closed circle since we have less than or equal to, shaded to the left. And a closed circle at 2, shaded to the right. So any of those numbers on those two lines would work. For example, 3, 5 times 3 is 15, take away 2 would be 13, that's going to be greater than or equal to 8. If I took negative 2, negative 10, minus 2 is negative 12, the absolute value of negative 12 is greater than or equal to 8. Problem number 10. We have the absolute value of 1 plus 8c is greater than 23. So again, we have the Egyptian. 1 plus 8c is greater than 23. Or, this is always an or statement, 1 plus 8c is less than negative 23. Solving for c, subtract 1. We get 8c is greater than 22. Divide by 8, and we get c is greater than, not equal to, excuse me, is greater than 22/8, which will simplify to 11/4. Or, bring that down, solving the second inequality, subtract 1, we get 8c is less than negative 24. Divide by 8, and we get c is less than, simplifying that, divide by 4, we get negative 6. Well, actually, it's just negative 3. Okay, graphing it, it's going to be an Egyptian. And we have negative 3. 11/4 is 2 3/4, so it's going to be between 2 and 3, so this is 11/4 right here. And we have an open circle at negative 3 shaded to the left, open circle at 11/4 shaded to the right. And this is our solution. Problem number 12. We have the absolute value of x over 2 minus 3 is less than or equal to 2. That's a between problem. That's the Russian elbows. So we put x over 2 minus 3 between 2 and negative 2. So solving for x, we're going to add 3 to each part. And we get 1 is less than or equal to x over 2 is less than or equal to 5. Get rid of the 2, we're going to multiply by 2. So we end up with 2 is less than or equal to x is less than or equal to 5/2. And then graphing it, this is 2, 5/2 is 2.5, so that would be between 2 and 3, we'll just put 5/2 here. So we have closed circles at 2 and 5/2 since we have the less than or equal to and shaded in between. The next set of problems are going to involve some extra work because either we're going to be turning inequalities around or we're going to have to get rid of some what's on the outside of the absolute value. So number 14, we have the absolute value of 6 minus the quantity 2y minus 3 is less than or equal to 9. We need to simplify the inside before we start. So this is going to be 6 minus 2y plus 3 is less than or equal to 9. And adding the 6 and the 3, we get negative 2y plus 9. The absolute value of that is less than or equal to 9. If you don't do that, you just have yourself a lot of extra work. So make sure you simplify always. So this says less than. That's going to be a between problem. So we have the compound sentence, an and compound sentence between 9 and negative 9. Solving for y, we are going to subtract 9 from each part. So we get negative 18 is less than or equal to negative 2y is less than or equal to 0. Then we're going to divide by negative 2, which will turn the inequalities around. So that's 9 is greater than or equal to y is greater than or equal to 0. Note the numbers are not in the correct order, so we turn it one more time to get it ready to graph. So it's all of the numbers between and including 0 and 9. So here's 0, here's 9. We want a closed circle for each because we do include our elbows and shade it in between. Problem number 16. We have 2 times the absolute value of 3k minus 7 plus 11 equals 19. Now we have to get rid of what's on the outside of the absolute value, so first we're going to undo the addition by subtracting 11. So now we have 2 times the absolute value of 3k minus 7 is equal to 8. Then we're going to divide by 2. And now we finally have 3k minus 7, the absolute value of it is equal to 4. So that's the bullhorn. So we have 3k minus 7 could equal 4, or 3k minus 7 could equal negative 4. Solving the first one on the left, we'll add 7 to both sides. We get 3k equals 11. Divide by 3, and k could equal 11 thirds. So if I put 11 thirds back into the problem, I'll get 11 minus 7, which is 4. 4 times 2 is 8. 8 plus 11 is 19, so that worked. Or, don't forget the or. Solving this one, add 7. We get 3k equals 3. Divide by 3, and k equals 1. So if I put 1 back in here, 3 minus 7 is negative 4. That still comes out positive 4. Times 2 is 8. Added to 11 makes 19. So our graph are the bullhorns. So this is 3 and 2/3. 11 thirds is 3 and 2/3. So here's 1. And here's the 11 thirds. It's between 3 and 4. And we just put the 2 dots down. And that was problem number 16, and our last problem, number 18, is 21 equals 4 times the absolute, I'm sorry, that's wrong, 21 minus 4 times the absolute value of 2 minus 5w is greater than 13. So again, we have to get the absolute value by itself. So we'll subtract the 21 first, undo the addition. So now we have negative 4 times the absolute value of 2 minus 5w is greater than negative 8. 13 minus 21 is negative 8. Then we divide both sides by negative 4, which will turn the inequality. So we get the absolute value of 2 minus 5w is less than 2. So it's not going to be Egyptian, it's going to be Russian elbows. So we're going to have 2 minus 5w will come between 2 and negative 2. Solving for w, subtract 2 from all 3 parts. And we get negative 4 is less than negative 5w is less than 0. Divide by negative 5, and we get 4/5 turns inequality is greater than w is greater than 0. Okay, that's not in the correct order to graph, so we turn it around. 0 is less than w is less than 4/5. And then graphing it, it's going to be the Russian elbows. We have a point at 0 and a point at 4/5, which is close to 1. Open circles shaded in between. And that concludes the evens. So be sure and check the odds, the answers in the back.